Hey everybody, I'm back. Ripley here, and we're going to move on to the next section in Chapter 6, Sampling Distributions. On the face of it, it almost seems too simple, but it's something very, very powerful. All right, they're called sampling distributions, and parenthetically I wrote of size n. All right, so I'm going to have to give you some vocabulary here. All right, and there are four things that we're going to discuss here. There are really three things that are important, but we're going to talk about a sampling distribution of any statistic, of a statistic. Okay? Now, don't get too hung up on this. It gets far more important when we start talking about sampling distribution of means, of proportions, and of variances. All right? But all that it is think of it this way. It's the distribution. It's the distribution. Remember, distribution is just the way that it looks when we graph it. It's the distribution of a certain value or statistic or stat. I'm just going to write it stat. When, now this is the most important, all possible samples of size n are taken from the same population. The sample population? Let's try that again. The same population. Now, it sounds a lot like wordsmithing, and to a certain degree it is, but I'll explain that in just a sec. All right, from the same population. So, check this out. I'm going to write the sampling distribution of the means, or just of means. Okay. And then I'm going to say, well, actually, we'll talk a little bit about this. Let's say that our population is gifted kids, okay? And I want to figure out the sampling distribution of the means of size 5 of, so we're going to say, let's write this over here. We're going to say this is our gifted kids, and this is going to be our population that they're coming from, okay? Okay, and we're going to let n, our sample size, be 5. Let's keep it simple. Let's go, we're going to ask them the number of siblings. Okay? So, let's talk about what a sampling distribution of the means is. All it means is this, no pun intended. The sampling distribution will take all possible samples of size 5 from the gifted kids population. That's the entire population. Now, I realize it's not practical, it's not feasible, and it's not possible to do that. But the sampling distribution is a theoretical construct, okay? That's what's really the most important thing that you get out of this. So if I take all possible samples of size 5, and I ask those samples how many siblings they have, and I write it down, and then I write down their mean. All right? If I grab 5 random kids and I find their mean and that equals a number, let's say it equals 3. And then I take another mean, so let's call this is my first sample. My second sample, okay? They have a mean of 2.6, and my third sample has a mean of 1.9, etc., until I can grab all possible samples of size 5 and figure out the average number of siblings for each one of those samples. That is called the sampling distribution of the mean. In this case, it would be a sampling, whoa, that was supposed to be a G, sampling distribution of n equals 5. That would produce a certain distribution, and we'll talk about what that would mean in just a sec. Okay? Now let's do exactly the same thing. We're going to grab a sampling distribution of size 5, okay? But instead of a sampling distribution of the means, we're going to talk about a sampling distribution of the variances. Okay? Now, we're going to do exactly the same thing. So it's still going to be n equals 5. N could be 15, n could be 2, n could be 75, n could be 135. N is it's chosen however we want it to be chosen. We would just say that it's a sampling distribution of the variances of size n equals 12. Who cares? I just chose 5 arbitrarily. Now we're going to do exactly the same thing, only we're not worried about the means for the sampling distribution of the variances. We're worried about the variances. So let's say this was 1.2 for the first one. For the second one, that's supposed to be an S, not a 5. Let's say it was, I don't know, 5.1. This one was crazy. For the third one, let's say that the sample variance was 0.8. Okay, and we would grab all possible samples of size n equals 5, and we would find the variance. The variance of each one of those samples, and that would give us the shape, it would give us the distribution of those variances. Now, let's check this one out. This one's going to change a little bit. It changes, so I'm going to write it out. Dist of proportions. Okay? Now, we're going to change this up. So instead of talking about the average number of siblings in the sample, on all possible samples of size 5, and the variances of the number of children, let's say that we rewrite the question. Instead of just asking how many siblings do you have, we say, do you have any siblings? And now what we're going to do is we're going to find a sample proportion, which is P. It's kind of like a probability. The sample proportion, you'll sometimes see this written, sometimes you'll see this written as P hat. That's a sample proportion. All right, it's got a little hat on it. That's why they call it P hat. So I grabbed 5, and let's say that 1 out of the 5 didn't have any siblings. All right, so the proportion of kids that had siblings would be 0.8. Let's say that P hat 2 was 1. So all of them had, okay? Let's say that P hat 3, remember these are this is sample number 1 of randomly chosen. Let's make sure we understand that. All right, we're just randomly choosing all these guys. We're grabbing, back that up. Let's make sure that we understand. A sampling distribution means that we grab every single one of the possible samples of size n. All right? So throw out what I just said about randomly choosing them, because by the time everything's said and done, we've grabbed them all. All right? Let's say that the sampling proportion for this question, for the third sample that we have is, I don't know, 0.4, etc., etc. That will produce, as long as I can get all possible samples of size n equals 5, that will produce the sampling distribution of proportions. All right? Now, that's a vocab term. All right? I think that we often think of a sampling distribution as being a verb rather than a noun. We're sampling. I guess that's a gerund, isn't it? We're going out and we're sampling stuff, and we really are. But the sampling distribution is the thing that happens. It's the shape of the distribution after we've chosen all possible samples of a fixed n. Again, that n can be any size. Now, what's really magical here, what really is the most cool thing about this, and it's the most useful, is, we'll pop over a page,